Hi all. So I am Manasa, and my machine learning project is personalized medicine, redefining cancer treatment. So we have a saying that the purpose of life is to live it, to taste it, to experience to the utmost, to reach out eagerly and without fear for newer and richer experience. But unfortunately, some of us who are surviving cancer patients cannot have this kind of life because of many things that are prevailing in the medical industry. First of all, it is a traditional method of treating the patients, and for few of the patients, the treatment is the treatment works. For the other patients, it does not work. And yeah, so because of many challenges existing, this is not what like most of us like every one of us get. Like, there are few patients who are suffering from cancer and they will not be able to get that kind of life. So, coming to the estimated cancer patients, so this is an information which I saw in Global Cancer Observatory, wherein there were 19.3 million cases in 2020, and that is expected to be 32.2 million coming forward. So, how are we going to treat this, and how better we can do this is entirely what my project is based on. So, the main motivation behind the project is how a precision medicine can improve the cancer treatment, as well as provide a personalized medicine to the cancer patients according to their biological and according to their reaction to the cancer treatment, whatever they are being given on. So the main motivation is that. And apart from that, in my life, I have seen many of my family members suffering from the cancer, and that really motivated me in looking for a way where technology can actually help providing a better medicine for the patients and improving their survival rates. So mainly the motivation is, yes, it is improving the survival rate of the cancer patients. And coming to the introduction part, so usually we know that the cancer treatment is a traditional way, and it is the general methodology which is followed for each of the patients. So it is not different for a patient based on his own or her own biology. It is a general treatment, and they will see the reaction of the patients, and in few cases it would be successful, and in majority of the cases it is not as successful as we see. So how precision medicine can offer a new approach to the cancer treatment, and that can take into account the unique biology of the patient, resulting in better outcomes, fewer side effects, and improved quality of life. So this is how it is. Like, we take the patient group, and then we follow like DNA sequencing, and then we give separate treatments for each of the patient groups, and then see how the treatment outcome is. And yeah, so definitely machine learning has a major impact in this area, because the algorithms can be used to analyze the clinical as well as the genomic data and make more accurate predictions about how a patient will respond to the treatment. So, the challenges in implementing precision medicine include sequencing the genes, interpreting genetic data, and logistical issues such as data sharing and privacy. Of course, privacy is a major concern, because even I personally felt very tough to find proper data that can actually give me a problem to solve. So, yeah, precision medicine also has the potential to revolutionize the cancer treatment and improve the outcomes for the patients by providing more effective, less toxic, and tailored treatments for each individual patient. So, what is the problem we are trying to solve? So, by now you must have got a rough idea that we are trying to solve a classification problem. So, the data set what I had or what I found was basically a classification problem, wherein we have a clinical based data, wherein we have the analysis of the past DNA sequences, or the past interpretation of the DNAs. And based on that, usually what is happening right now is manually a clinical specialist, a pathologist, will actually start finding out what kind of mutation it is based on the existing based data which is there from the past clinical history of the data what we have. So how machine learning can help this problem? So uh, our main goal, the main aim of the project is improving the accuracy of the cancer treatment, and in this we are trying to use the machine learning models and the algorithms in order to make this process automatic. So where the process is happening manually, we want to make it automatic, so that we get good amount of accuracy, and we can give personalized treatment for each of the patients. So coming to the project part, what how it started and what was the analysis. So the data, I tried finding out on the news or KPI. However, like I was actually surprised to see initially that within a span of 15 days, there were almost 56 articles that were there on cancer. Means we can see the amount of importance for this topic, and yeah, life is all what we want to experience. So for that, yeah, definitely technology can play a really important role and improve the cancer treatment what we have right now. So the newsorg API data did not help me much because it was all article data and I could not do much from that. However, I later started searching on the Kaggle, and then from the Kaggle API I got a data set which is almost and almost not almost, it's perfect for my problem what I want to solve. So yeah, the data set which I followed was from the Kaggle majorly. So this is from the newsorg API. That was the raw data, and this was the formatted data, like after converting it into the CSV and then cleaning few of the things. And this is from the Kaggle API, which I majorly based my project on. So it basically had the text format data that again I made it into the CSV and into different formats of dataset based on the analysis I was doing. So yeah. And what were the initial challenges which I faced when I started the project? So first problem was searching for the data, and that was really hectic, and it was very tough because it is very tough to find medical data because of the privacy concerns. It will not be available readily on any of the websites, and yeah. So even when I wanted to check through the APIs, it was taking a lot of time for them to actually give me the key to get the data from their particular API of their website. So I had to rely on Kaggle API data, which I found through the Kaggle website. So when I found the data, it was entirely text data, and I had no clue on how to work on that because uh, you know that not everything was, we are dealing with the machine learning classes on text. So I initially found it really tough working on the text data, and I could not find better resources for the data as well other than the Kaggle. And the understanding of the data, yes, it definitely needed prior understanding and how it is being done, and what we are trying to do, and how we are trying to improve the process of what is being already done manually. So these are some of the EDA's exploratory data analysis what was done as part of the project. So the first one was, I mean, basically the data had seven different classes into which the genes were categorized. The basically the mutations were categorized. So and the first one is the pie chart of those class variables of their distribution, and then we have the histogram of gene variables whatever we have, and the this one is nothing but the word cloud of the text data what we have from the clinical database what I had in my project. And these are the few of the exploratory data analysis what was done. And what were the interesting findings? So there are some interesting findings when I did this association rule mining, but that does not mean those were accurate or appropriate, because this is a medical data, and even though we find relations between certain mutations, it might not be appropriate, or we cannot really confirm it until and unless we have a broad knowledge of medical data. So, of course, there are some interesting findings on the subset genes and the rules formed between them, which indicate there is a possible correlation between the genes. However, as I said, it cannot be confirmed since I myself don't have a lot of broader knowledge in the medical data. And yeah, not all rules which we get can be extrapolated or generalized when it comes to the medical data. And then uh, yeah, so I have used other machine learning algorithms such as Navy based, etc. However, with SVM, there was a potential and highest accuracy which I received, and that was 67%. So, to access the performance of the SVM, I have tried linear, RBF, and polynomial kernels. And then I found this particular accuracy with RBF kernel for a cost of 10. So these findings implied me that SVM model is one of the best models for classification, and it can definitely deliver precise and trustworthy outcomes when applied to classification tasks. And yeah, coming to the conclusions part. So, the machine learning algorithms have definitely potential in improving cancer treatment through precision medicine. And what dataset was considered was one of the largest datasets available. It was of 33,000 cancer patients, which was used in the project. And yeah, precision medicine through this way actually can provide tailored treatments to specific cancer subtypes or mutations, resulting into better outcomes and reduced costs. So, challenges in implementing this precision medicine include interpretation of genetical data, and though we find few results, we will not be 100% confident on that because it definitely needs prior experience or prior knowledge on what we are working on, and it would also involve logistical challenges such as data sharing, privacy concerns, etc. Because definitely it involves people, and when people are involved there would be definitely privacy concerns, and usually it will not be shared publicly for any of the analysis we want to do. And the analysis entirely suggested that there is an effective way in analyzing sizable data sets, provide precise and reliable outcomes for classification tasks on similar data sets. So if we have any area in medical side where we can actually implement machine learning algorithms, classification is one of the major area where we can concentrate on, and that can definitely give better outcomes and improved medical treatment. Like it can also give definitely a precise medicine to the cancer patients or any other kind of patients which they want personalized treatment. So in conclusion, yeah, during this project I faced a lot of issues working on text data. However, it was fun working with that, and since it's a medical field, so I had a lot of interest because I never worked on such kind of data before. It was really interesting. However, there are considerable roadblocks as well which I faced, and yeah, overall it was a good accuracy is what I could see. Maybe going forward, like if in future if we apply neural networks or regression methods on this, maybe we can try to see if we get better results. However, I could see the accuracy what I got is fine, and uh, yeah, so there are future definitely improvements on this particular thing. Yeah. Yeah, so thank you. And with this project, I tried to like follow the saying and provide a better experience for the cancer patients. Yeah, I hope I tried to use what I know and provide them with a better personalized medicine and improve their survival rate. Thank you.